we are about to revise continuity again. So in PUC1 you studied Channa Keshav, I am here. In PUC1 you studied limits. Do you remember that? Yes. Do you want me to revise limits again, or should we do continuity? No. I'll just quickly tell you. What was limit? What was limit? In PUC1 you studied limits, right? Huh? What was limit? What is the meaning of limit? Limit was basically understanding how a function of x, if you have the variable x, how a function of x behaves. Limit was basically understanding how a function of x behaves when the variable x does not exactly take a value but tends to go towards a value. Say for example, you have the value 0, 1, 2, 3 like that. If I take, suppose x tends to go towards 1 but never exactly reaches 1. Then how will fx behave? How will a function fx behave? It will also behave in a similar way. It will also tend to go towards some particular value. The function fx will also tend to go towards a particular value but will never reach that value. Then that value for fx will be called the limit of fx. Now, when suppose instead of 1 in general if we take a, then when x tends to go towards a but never exactly reaches a, then the function fx, any function of x, it can be a polynomial function, x square, x cube, these and that, it can be a trigonometric function, sin x, cos x, anything, logarithmic, log x, exponential, e power x, anything. Any function of x, it will also behave in a similar way. It will tend to go towards a particular value but will never reach that value. Then that value will be called the limit of the function, isn't it? We studied it in PUC1, right? Now what is continuity? For that, let us quickly remember a few things like, say for example, see, the variable x can go to this a from this side, isn't it? Coming to a from the left side of a. Left side of a means values less than a. Say, suppose if a is 1, x can start from 0.2, 0.3, 0.5, 0.8, 0.9, 0.99, 0.99999 like that. Coming to 1 from the left side or coming to a from the left side. Then the number towards which or the value towards which fx will also behave in a similar way, that particular value will be called the what? Left hand limit of fx. What limit? Left hand limit of fx, and we write it like this: limit x tends to a minus fx, isn't it? When x goes to a from the left side of a, then the function fx will also behave in a similar way towards a particular value. That value will be called the left hand limit of fx, isn't it? And how do we write it? Limit x tends to a minus fx. This limit, we can write it LIM or we can also write it as capital LT. You can write it LIM or you can also write it capital LT. Same thing. Any one you can prefer. Okay. So this is called the left hand limit of fx, isn't it? When x goes to a. Similarly, if we consider the other case, that when x comes to a from the this time right side, that is from values greater than a. Right side means greater, no? So if x this time comes to a from the right side of a, then the limit of the function fx, that will be called the right hand limit. That will call the RHL, right hand limit. And how do we denote it? Limit x tends to a plus f of x. Limit x tends to a plus f of x, isn't it? And when these two right hand and left hand limits when the left hand and right hand limits, they both exist. Sometimes it may happen, the limit values may not exist. They may go to infinity, they may be undefined, they may not exist. If both these limits exist and both of them are equal, if both of them exist and are equal, then we say that the limit of the function f exists at x equal to a. The limit exists at x equal to a, and that limit value will be equal to each of these values. Say each of them is equal to the value L. Then we say that the limit of fx exists at x equal to a and the value is L. Okay? Isn't it? Now, what is continuity? What is continuity? Continuity is basically defined like this. Continuity is basically defined like this. A function fx is said to be continuous at a point. A function fx is said to be continuous at a point, say C. When is it said to be continuous? If limit x tends to c f of x, the limit value exists. Okay, we took a, na? Let us take a. A function fx is said to be continuous at a point x equal to a when the limit of the function exists at x equal to a, and that value of the limit will be equal to f of a. That is, it will be equal to the value of the function at the point. The value of the function exactly at the point. Because we know that what is the limit value? Limit value is not like exactly going there. Limit value is like it tends to go there but never reaches there. So if we see that the limit, are you okay? You need water? Give us some water. If we see that the limit value of fx exists at x equal to a, the limit of fx exists at x equal to a, and that limit value, that limiting value is exactly equal to f of a. It is exactly equal to the value of the function at x equal to a. Then we say that the function fx is continuous. Function fx is continuous at x equal to a. Fx is continuous at x equal to a. When? If this. Clear? If this. How will it look like? Say if this is the point A, then the graph of fx will look like this. It will be definitely continuous at this point. The graph of fx will look like this. Somewhere it may look like this. Say, look at this point. At this particular point, is the graph of fx continuous? No, there is a break. There is a jump. There is a break. It is not continuous. But if it is continuous at x equal to a, it will definitely look like this. The graph will be what? Continuous. There will be no break. Isn't it? So in mathematical language, in formulas or in terms of expressions, how can we write it? Fx is continuous at x equal to a if the limit of fx at x equal to a will be equal to the value of the function at x equal to a. Okay? This is the definition of continuity. This same definition we can also write it in another way. What way? From the definition of limit, we know that the limit value of fx at x equal to a is actually nothing but equal to the left hand limit and the right hand limit. Yes or no? So we can write this definition in an expanded form. What expanded form? This is actually equal to the left hand limit. Yes or no? What do you know? The limit will exist. Just now we revised. The limit will exist if the left hand limit equal to what? The limit of fx will exist at x equal to a if the left hand limit equal to the right hand limit. is the left hand limit equal to the right hand limit. So the definition of continuity, we can also write it in this way, that the left hand limit of fx should exist at x equal to a. When x goes to a, the left hand limit of fx should exist, and that should be equal to the right hand limit of fx when x goes to a, and that should be equal to the value of the function f at a. Clear? Is it clear? So this is your basic definition of continuity. Any questions till now? We can use any one of these definitions. Basically, the first one is the definition of continuity. The second one is the expanded form. In the expanded form, we can say that what? When does the limit exist? The limit exists of a function fx at any point x equal to a if the left hand limit of fx when x goes to a is same as the right hand limit when x goes to a. When both left hand limit and right hand limit will be equal, then the limit exists, no? And that should be equal to f of a. What is this value? This value is actually equal to this and this. This value is actually equal to this and this, L. Yes or no? So sometimes in some questions, you will be needing to use this one. You may need to use the first one or the second expanded form, depending on how your question is given or depending on how your function is defined. Okay? Quickly note it down. Anyone who wants to note it down, quickly do that. Note down both the definitions if you want to do that. Done? Are you okay? Drank water? Okay. Any questions? Anyone? Any queries? Gagana? Mati? No. No. What happened? Don't feel like writing? Okay. No worries, no worries. Okay, very good, no worries. Your copy, your studies, your wish. What to say? You feel like saving your ink? You can save your ink. So when is fx said to be continuous at any point x equal to a? When the limit of fx at x equal to a will be equal to value of the function at a, f of a. Isn't it? Or we can also say it in expanded form, when the left hand limit equal to the right hand limit. When the left hand limit equal to the right hand limit also equal to the value of the function at a, then we say that the function is continuous at x equal to a. Okay? Clear? Noted? Can I erase the board? Everyone? Okay. So as I said, sometimes you may need to use the basic definition, limit x tends to a, fx equal to fa. Or sometimes you may need to use the left hand limit, right hand limit and this. When do you need to use the first one and when do you need to use the second one? When do we need to use the first one and when do we need to use the second one? The first one we need to use if your function is defined in the same manner when f does not go to a. If your function is defined in the same manner when x is not equal to a, and in a different manner when x equal to a. And the second one we will use if your function is defined in one manner when x is on the left side of a. For that you have to find left hand limit, and the function is defined in another manner when x is on the right side of a. For that you have to find the right hand limit, and a function has a third definition when f goes to a. Isn't it? Let us see, for example, do this question. Find, this is the most common type of questions which is bound to come in your exams. Find the value of k such that the function f is continuous at x equal to 3. And your fx is defined like this. My mistake, just a moment. Noted? Is it done? Okay. So how to do this question? Find the value of k such that the function f is continuous at x equal to 3. K is minus 30. Minus 30. Okay, see here. So, tell me one thing. In this, the given function is f, isn't it? Now, this given function f, is it defined in a separate way on the left of 3 or right of 3? No. If x is equal to 3, there is a definition. But if x is not equal to 3, there is a single definition. That means, when x is on the left of 3, it will follow this definition. And when x is on the right of 3, it will follow the same definition, isn't it? On the left and on the right, it will follow the same definition of f of x, isn't it? Your function f will follow the same definition when x is on the left of 3 as well as on the right of 3. That is why here which continuity definition will you use? First one, isn't it? Which condition? First one. There is the direct definition. What is the definition? Yes. Here what is given? fx is continuous at x equal to 3. So if fx is continuous at x equal to 3, since fx is what? Continuous at x equal to 3. Therefore, by definition, what do we have? Limit x tends to 3, f of x should be equal to the value of the function f at 3. Value of the function at 3. So now, what is the value of the function at 3? 4. And when x goes to 3, when x is going to 3 or approaching 3 or when x tends to 3, how is the function fx defined? When x goes to 3, what is the idea of limit? The idea of limit is that when x goes to 3, it never actually reaches 3. It will reach very close to 3 but never exactly becomes equal to 3. That means you have to use the definition when x is not equal to 3. Yes or no? You have to use the definition when x is not equal to 3. And what is the definition of fx? 2x minus k by 2x plus 3. That should be equal to 4, isn't it? That should be equal to 4. Clear? Manas? Now evaluate the limit. How do you evaluate limit? Put directly x value here, isn't it? If it has a value, we can proceed. But if it comes out to be in one of the indeterminate forms, we cannot proceed. We have to apply some special method. Do you remember the indeterminate forms? While evaluating a limit, if the limit value comes out to be some indeterminate form, 0 by 0, infinity by infinity, 0 power 0 or infinity power infinity. If the limit value comes out to be one of these indeterminate forms, we cannot directly evaluate the limit, isn't it? Indeterminate forms. Indeterminate means the limit has no definite value. The value cannot be determined. isn't it? Indeterminate, value cannot be determined. Then we have to apply some specific rules in limits you studied in PUC 1. You have to apply some specific rules like rationalization, factorization, some methods you have to apply. Or we can apply L'Hopital rule. Maybe we need to apply L'Hopital rule. When do we apply L'Hopital rule? For 0 by 0 or infinity by infinity, isn't it? Mostly we find for 0 by 0. We have to apply what rule? L'Hopital rule, isn't it? Like that. So